So many times I've had talks already about ocean fertilization that I don't want to, I might use the same title if I'm not watching
Many
out.
times I've had talks of
Okay, so here we are. We are, I believe, now live. YouTube has changed where they show things just to make me confused. That's the only reason. But we are now live, I guess. We're certainly recording. So, all right, let's get going. Hi, I'm Meta Spencer. Today we're going to take some trips to Australia and to Canada, where we're going to talk to somebody who's driving a car. And so that's okay. We're going to have a good conversation about the oceans and what we can do to help global warming, to prevent global warming, or curtail it by things that we can do with the oceans. And maybe, and that's a bit controversial. So we will have a discussion about whether or not we believe such things are possible, and if so, how it would work. Okay, my two guests today are Robert Tulip, who is, he's spent most of his career working for the government of Australia, I think, on development issues. And he's sort of a philosopher and I think, a Christian activist or something. We won't go there, but at any rate, hi, Robbie. It's nice to see you today.
Thanks so much,
Uh,
Meta.
yeah. Okay, and in his car, someplace yet to be disclosed, is Jason McNamee. And Jason, I have not met before, but he's the founder of Lucent Bio, which is based in Vancouver. He's a senior biogeoscientist with experience from the Ocean NAMA network, whatever that is, NAMA. We're going to find out more about his outfits in a minute, I think. World Aquarium and Conservation for the Oceans Foundation. He has a degree in science from ecology and geology from the University of Regina. So, hello, Jason. How are you? And how are things on the road today?
Hello, Meta, and hello, everybody. Nice to meet you. Things are great. I am in Saskatchewan, Canada, which is where we have a manufacturing facility, and I'm just on my way to that facility now.
Well, hot diggity. Tell me what kind of things you're manufacturing, please.
Well, sure. I'll give you a bit more about my background. So, as you said, my degrees are in ecology and geology. I spent 15 years doing geotechnical and environmental engineering projects all over North America. Then in 2010, I founded, along with the folks from Old Massett, the Highest Salmon Restoration Corporation, which conducted an ocean fertilization experiment in 2012. That technology came with me to my next company, which is Lucent Biosciences, where we actually patented the methodology to calculate the carbon sequestered from ocean iron fertilization. You can get that out of Google Patents if you like. Also patented how to make improve seafood outcomes from ocean iron fertilization. And what I'm doing here now is we also developed an entirely new composition of matter, whereby we attach crop nutrition to cellulose. We use waste cellulose from the food processing industry, like oat husks, rice husks, those sorts of things. We hammer mill that into a fine powder. We then put it through a proprietary reaction, whereby we attach crop nutrition, particularly large cations, to the material. We turn that into a dry granular fertilizer. That fertilizer is then blended with urea, phosphorus, potassium, etc., and goes into farmers' fields to improve yields and soil health. The material also ends up sequestering carbon. The cool thing about it is that we give a very high nutrient efficiency, because our nutrients are attached so tightly to the cellulose that they don't leach or tie up, and in fact, our material is water insoluble. However, the cellulose in the product is a food source for the soil microbiome. And so when the soil is warm and moist, which is when your plant is growing the most, that's when the nutrients are released. So it really allows growers to maximize the genetic potential of their seeds. So that's what I'm doing in Saskatchewan.
Well, hot diggity, that is wonderful. Now, I want to probe a little bit on that. Would you call your product made from seaweed?
Sorry, say again?
I have a special reason for wanting to ask whether what you produce could be called the derivative of seaweed.
I don't think so. No.
You make it from phytoplankton, or what is the basic ingredient?
The basic ingredients are cellulose, which we get, which is oat hulls or rice husks, that sort of thing. So it's a waste product from the food processing industry. That's the base of our fertilizer.
Mm-hmm.
But that's quite separate from the ocean iron fertilization work. So maybe, Meta, we should go back to the ocean iron fertilization interests that Jason has.
Actually, not really.
Okay.
So we actually developed this product because in the course of ocean iron fertilization, we recognized that a lot of the iron that we added to the ocean actually oxidized quickly and or wasn't used up. So we were only getting about a 10 or 15% use rate of the iron. So what we did is we found a way to attach the iron to this cellulose product, and so that would feed the iron in a bioavailable form, but also in the photosynthetic zone. We had this material tested versus this typical iron sulfates or iron gluconates through National Science and Engineering Research Council grant from the Government of Canada. It was tested by the Canada Research Chair in Phytoplankton Physiology, and it did determine that our material works about an order of magnitude better than the usual iron product. So that's where the germ of the idea came from. We pivoted to agriculture because, agriculture is a much easier story to tell to the public, and it's a way to commercialize the intellectual property we developed.
Because there's a big ban on ocean fertilization, which is really quite extraordinary. So the London Convention and Protocol and the Convention on Biodiversity have defined all efforts to fertilize the ocean as the dumping of waste. And so, whereas the intent of what Jason was doing was, as I understand it, correct me if I'm wrong, Jason, was to improve the overall health of the ocean. The view of the United Nations system is that it's actually a malevolent form of dumping of pollution, and that's been accepted by all the governments of the world, and so I can understand why. If Jason's interested in the commercialization of these concepts, then it's just extremely difficult to do anything in the ocean because of the toxic politics that surrounds it.
Mm-hmm.
Jason, is that correct?
Somewhat. I would say that the London Convention, London Protocol, it's not a ban. You need a legal scholar in here to have this discussion.
It's a limitation to scientific testing in coastal waters, and so there's quite strict limits that are placed on what can be done.
But I would also say to you that a lot of the large, like for instance, the United States is not a signatory to the London Convention, London Protocol, nor are they a signatory to the law of the sea, and neither. So, Italy, NGOs and certain academics and certain governments are trumpeted as a ban. It's not a ban, but it's a de facto ban because there's really, it's very difficult to do work in the deep sea, particularly when there's the vocal folks against it.
Yeah, I meant de facto. It's not de jure. Yeah, it's not a legal ban, but it's a political barrier.
Agreed.
Okay, let me back up and tell you why I was interested in whether or not you could call your product a derivative of seaweed. One of the things that I've been doing is making these talk shows for a couple of years or more about interventions that are meant to counteract the effects of global warming, sometimes referred to disparagingly as geoengineering. And there are many, many different proposals that are relevant, but I've covered a lot of them. But I just recently made a course on Udemy, which people can take for free by signing up on Udemy, which is that learning platform that there are millions, something like 50, 60 million people who take courses through them. And I created this course called Become a Climate Change Influencer. And it's basically to teach people who want to become activists in the campaign against global warming and who need some training on certain skills that could make them more effective. But what I did is I picked just one of these climate repair interventions, proposals, and used it as the technology that I wanted to train people to become activists in. And of course, anything that they learned in that course could be applied in respect to other interventions that are also climate repair interventions. So anyway, I picked the notion of using soil amendments as the easiest and the least controversial of all of the proposals for climate repair. And so that is what I train people to learn how to become activists by practicing on that particular issue. So I got clips from at least 5 different shows that I'd produced about usually enhanced rock weathering, but I also included material on how other soil amendment ingredients are produced, because I think seaweed is a wonderful soil amendment that also can capture and sequester carbon in the soil. And of course, biochar, which isn't really a fertilizer, but which is very great thing to add to both rock dust and the seaweed. So when I heard you talking about things that you could be using in ocean iron fertilization, it occurred to me that maybe your ingredient was something that could be called seaweed, because I would call ocean I would call phytoplankton a kind of seaweed, microscopic seaweed, but at any rate, it could be used in various ways. So that was why I asked about that, and I'm not sure how much your ingredient could be added into the list of 3 different elements that I use or that I encourage people to promote as ways of sequestering carbon: the rock dust, the biochar, and the seaweed. Maybe we should add a 4th one, that is rice husks with iron in it. So there you go. What do you think?
Well, I mean, in fact, our product does sequester carbon. We've had independent third-party testing, desktop testing that was done by a company called Veresco based out of Canada. And they figured that for every ton of our product that's applied to crops, we sequester about 3 tons of CO2 equivalents. Because of that, last year we won the Shell Climate Smart Agriculture Award, and Shell invested in us to help us prove those claims in the greenhouse and in the field. So we've just completed that work, and in fact, the number is higher than 3 tons per ton. We don't know exactly what that number is, but we think it's about 10 tons per ton of our product. So our company will actually end up being a climate positive, or a company that sequesters more carbon than it releases.
Excellent. Good for you.
Through this activity. Yeah.
All right. Can you compare the effectiveness as in carbon sequestration of your product with that of rock dust, seaweed, and biochar? It'd be interesting to me to know whether we are betting on the wrong horse.
In the soil, you mean?
Yeah. Once it gets in the soil, how good is it as a soil sequestering mechanism?
Well, like I said, ours is 10 to 1 or something like that.
You don't know. I mean, you know how good yours is, but has anybody tried the same thing to say how good the other 3 things are?
I don't know that. I haven't looked in the literature for that at all.
Well, I haven't either, because I never heard of you before, or your game plan. Although I've heard of people using rice husks in a different way. There are people who believe that you could, maybe they've even tried it, I think, sprinkle rice husks on the oceans, because they're lightweight and they float and they're light color. And what this would do is change the create albedo effect on the oceans and reflect more of the light back out into space and have a cooling effect on the water. Eventually, I guess the rice husks sink, and maybe they get eaten by fish, and that would be a good thing too. But that was where I first heard of it. And then later, I heard that some people at the University of Cambridge a year or so ago had been experimenting by sprinkling rice husks on the water in one of the I don't know what, the Red Sea, or I've forgotten exactly what ocean area, but it was in the Middle East, and they were doing a big experiment, but there was a storm that came along and ruined the whole thing. I guess it made the rice husks sink or something. Anyway, you are not quite alone in your endeavor. So
yeah, well, that was Sir David King from Cambridge Climate Repair Institute, and he got that idea. He got that idea from us.
Well, good. Okay, so David is he's no longer running that, but another man. I talked to Hugh Hunt, who is an important figure in that movement, the Climate Repair Institute, or whatever it is they have at Cambridge.
Right. Jason, do you know Steve Clark, his work on buoyant flakes using rice husks together with iron as a ocean iron fertilization method?
Yes.
Well, isn't that what I was referring to, this buoyant flakes?
Yeah, and we talked about it. The difference with our material is our material remains bioavailable the entire time. Like the iron in our material remains, so it can be bioavailable for days, weeks, months, as long as it's in the photosynthetic zone. The buoyant flakes idea doesn't include a covalent bond of any sort. So that's where
Pardon me, but
our product
Yeah, you're
is,
breaking up a bit, Jason,
superior
unfortunately.
to that. But anyways, the other hard thing is like, oh, sorry. Yeah,
could you
go
move,
ahead.
could you just back up a sentence or two, because I didn't quite hear what you said. It doesn't, your thing doesn't include what?
So the difference between our material and the buoyant flakes is our material is covalently bonded to the iron, which makes it bioavailable for days, weeks, months. Whereas the buoyant flakes does not have a strong bond, and therefore you will get oxidation and a decrease in the effectiveness of the material.
Mhm. But now this buoyant flakes, I have not interviewed anybody who does that or promotes it, but that was what I thought I was describing when I said that you sprinkle it on the ocean and it increases the albedo effect of the ocean. That's the general purpose, isn't it, or the game plan for that, or
I
not?
think Robert, I think you can talk a little bit more to what the buoyant flakes are.
Yeah.
Well, I'd rather go on with some of the other aspects of ocean iron fertilization. I think there's a lot to cover, but I think Meta, I'm sure Sev Clark would be happy to speak with you. He's the inventor and advocate, and he's got a bunch of other really interesting climate technologies that he'd be able to share with you.
All right. Thank you. I'll get to him. Good. Oh,
Cool.
now I take your point that we should get on with our discussion about ocean iron fertilization, which in itself is a controversial topic. And I'm going to let you, Robbie, if you will explain the whole kind of the history of that intervention, that proposal, and because you know more about it than I'll ever know.
Sure. So ocean iron fertilization was first proposed in about 1990 by a scientist by the name of John Martin, who famously said, "If you give me half a tanker of iron, I'll give you a new ice age," because the science that's behind ocean iron fertilization is that across most a lot of the ocean has got a lot of nutrients, but doesn't have any iron. And for plankton to grow, it needs about one atom of iron for every 100,000 atoms of carbon that it has. And then it also needs phosphorus and nitrogen and potassium and a whole lot of other trace elements. So anyway, with this 1 to 100,000 ratio, that means that if you add this is the ideal theory. If you add one atom of iron, then you're going to enable the plankton to utilize 100,000 atoms of carbon, and so it will suck. Oh, we've lost Jason. So it will suck that carbon dioxide out of the ocean, and because there's a lot of dissolved carbon dioxide as carbonic acid in the ocean, and then it will form equilibrium between the ocean and the air, and it will remove that carbon dioxide from the atmosphere. So what happened was that theoretical recognition that you could potential, like, so if you add iron across the vast areas of the world ocean that are iron limited, they're called high nutrient, low chlorophyll regions. So they're ocean deserts, places where there's quite a bit of surface nutrient, but the absence of iron means that there's no that the plankton can't grow. And so if you add the iron there, then you're going to get algal blooms, and a lot of that algae will sink to the bottom of the ocean and sequester. And so it's theoretically a really good way to remove carbon dioxide from the atmosphere. And so there were a whole series of major scientific field missions in the first decade of this century that added iron sulfate to the ocean, mainly in the Southern Ocean, and then tested how effectively they had sequestered carbon. And they found measuring it really to be quite difficult. Just getting out into the field and measuring it was quite a challenge. Then as this research proceeded, various other people started raising questions about the side effects of ocean iron fertilization. So, for example, if you add iron in one place, then you'll create plankton in that spot, but all of those nutrients that are in the current flowing to another place, they won't have that same nutrient downstream. So you'd be robbing the downstream location of the nutrient that would have gone there otherwise. And then there's other issues like the oxygen level in the ocean and so on. But really the big complaint that people had about this is that it's a geoengineering technology. And the main complaint that people have about geoengineering is that it provides an excuse not to cut carbon dioxide emissions. And so people felt that this moral hazard argument was really very significant. And so they lobbied the Convention on Biodiversity in the United Nations, and also the London Convention and London Protocol, seeking to place a complete ban on field testing of ocean iron fertilization. Now then, in 2012, a entrepreneur by the name of Russ George worked with the and Jason can tell us perhaps more about this. Worked with the Haida indigenous community in British Columbia, because the way Russ saw it was that the salmon were could grow much better if you added algae at exactly the point in their life cycle where there wasn't enough. So the fingerlings come out of the rivers and into the ocean, and then if you target where they're in the ocean with iron, then they'll have plenty of food. So Russ did a field test of this, and his claim was that it was a really big success because they looked at the salmon yields in the next year, and they went up a long way. But it produced a really massive controversy because people said that he didn't have the proper approvals, and that it was illegal, and that he was a rogue geoengineer, and all these sorts of stuff. And so the government got involved, and the police and the SWAT team stole all of his research, and all of this sort of stuff happened. This is just the way Russ put it, and that led to the whole a really big chill over the whole space. This is my perception of ocean iron fertilization, and so there haven't been any field tests of ocean iron fertilization since 2012, more than a decade ago. Now, Jason might and there's been a bunch of people who've wanted to do field tests, but finding investment and so there's several groups that are quite strongly opposed. So the donors for the non-government organizations tend to be very hostile, and so organizations like Greenpeace, where they may have had some you know scientific sympathy, they've backed away because of the popular hostility towards the whole geoengineering aspect of it. And then the scientific community, the marine biology community, have expressed a lot of worry about the side effects and the risks of the side effects. Now, my view on that is that to understand all of those side effects, you need to get a balance between the risks and the benefits. And so you should be doing that. Like if the calculated benefits are very high, then you should be doing well-governed scientific tests to measure it objectively, rather than just making speculative claims about what might happen, because it just illustrates that there's such a lot of politics in this. And this goes into the moral hazard argument with the United Nations. So when the UN says we've got to cut fossil fuel emissions in half in the next few years, they see that this sort of technology undermines that objective. And so there's just a lot of political motivation to say, let's prevent any geoengineering field tests. So I might hand over to Jason in case I got anything wrong there, because he was quite involved with all of that.
Let me ask one question first, though, because I was not aware that apparently from your narrative, this John Marshall, not Marshall, Martin, did his work before Russ George. Is that right?
Well before that. He wrote a theoretical article in 1990, just setting out the scientific argument that there's that iron is the key limiting element for ocean iron fertilization.
Mm-hmm. Well, I wasn't aware of the discrepancy in time. I thought they were similar, but no. Okay, that's very important. Yeah, Jason. Now, is his story aligned with what the story that you would tell?
Yeah, somewhat. I would. There's a few things that I would add. Number one is there are tests that go on every year of ocean iron fertilization. Every year we get massive dust storms from the Sahara Desert, the Gobi Desert, sometimes Australia, and we get massive plankton blooms, not tens of thousands of square kilometers, but hundreds of thousands or millions of square kilometers in size. And you know what? None of those fears of nutrient robbing or bad phytoplankton ever happen. The only thing that happens is an improvement in fisheries. So I think that the proof, the rationale of the boogeyman of deep sea deoxygenation or nutrient robbing or those sort of things, I think nature already shows us that that's probably not the case, but we should go and test. So I think those risks are not as great as they're said. Number one. Number two,
sorry, if I could just add, Jason, do you mind if I just say one of
Sure.
in addition to the dust that's coming from the deserts, there's a lot of iron that's contained in volcanoes, volcanic eruptions, and so there have been some really major eruptions in Alaska that have produced bumper salmon harvests, and without any of these alleged side effects that people have been speculating about, which indicates that really those claims about side effects are politically motivated and not based on science.
agree. And you could also add icebergs to that. One of the reasons that the waters are so fertile around Antarctica is the ice in Antarctica is all, ice that has scraped the continent. And so it's got continental dust in it, and it's got iron in it. And that's why we have good plankton blooms all the way around Antarctica, and great krill hordes and whales and stuff down there. So iron fertilization is a natural process. We know that. So number one. I think all those alleged problems are, to Robert's point, more of a, let's call it a red herring, because we're talking about the ocean than anything else. So number one. Number two, the whole work that we did with the HIDA project, I really would like people to start referring to it as the HIDA project rather than Russ George. Because Russ George, I can tell you, was a part of that project, but it wasn't Russ George. It's not for the HIDA. None of that gets done. I served as a director on that company. I was a chief operations officer, and I was there long after Russ left. And Russ himself is a controversial figure, and he doesn't do himself any favors because he likes to exaggerate things. We just need to be honest about what actually happens. And so those would be the main things that I would say. I would also add that there are currently some organizations, like in addition to the Cambridge Climate Repair Institute, Woods Hole in the U.S. is looking at doing, well, they're raising money now to do another experiment. And I think it's important that that the next round of experiments are completed by government agencies and universities, but at the proper scale, like the Haida Salmon Project, whereby you can measure properly the carbon sequestration. And in fact, as I said, we developed a patent on how you do the measurement, and it's complex. We wrote that patent with a number of academics, and along with a agency out of Germany, TUV, that helped us write that methodology. So it's a difficult thing to do, but I think it's necessary to add credibility to the space. The other thing I'd like to say is this whole thing about geoengineering. I think this kind of work is actually reverse geoengineering, because what we're doing now is geoengineering. We know, like I'm driving to my factory, I know what the outcome is of that. We're changing the planet on a daily basis. We need to figure out how to reverse that, and we need all hands on deck to do that. Because if you talk to the NGOs and or academics who are against this sort of work, my question to them is always, how are the activities that you're undertaking changing the rate of carbon going into the atmosphere? And the answer is that we are emitting more carbon than at a faster rate year over year. So their activities are not useful.
Mm-hmm.
We need useful activities like ocean fertilization, or at least we need proper experimentation to tell us if it works and how well it works. We know that it works on a scientific wavelength because you may not be aware of this, but as I said earlier, my first degree was in geology. And I know, and you can look this up, that most of the oil and gas in the world comes from hundreds of millions of years of plankton growing and dying in the ocean. It doesn't come from trees or forests. It comes from the ocean. And really, another way to look at ocean fertilization is we just need to put that carbon back where it came from, which is the bottom of the ocean.
So, Meta, I might jump in and just add to what Jason's said there. about the risk analysis, because this idea that we're actually geoengineering the world now is a really important point. And so I had a look at the data from Mauna Loa in Hawaii, where they do very rigorous measurements of the carbon dioxide level in the atmosphere. And what they've been measuring it since 1959 for more than 60 years every day. And what they've found is that not only is the amount that we add increasing, but the rate of increase is accelerating. So all of the efforts of the Paris Accord, of the IPCC, of governments to allegedly cut emissions have totally failed, and we've generated a massive risk of climate collapse through tipping points. And the key tipping points include the melting of the Arctic and the stopping of the ocean currents, especially the Atlantic overturning. And so the risks of tipping points are so significant that we've seen the darkening of the world. So in the last 2 decades, the amount of sunlight that gets reflected back to space has fallen by nearly 2%. And that James Hansen, who's the most distinguished climate scientist, wrote a paper calculating that the loss of albedo, that's the reflection of light back to space, has been the equivalent of more than 100 parts per million of carbon dioxide. So we're completely failing in our efforts to slow global warming. And we have methods such as ocean iron fertilization that actually could work, but which are prevented. And so what we need is a comparison of the risks. So we need to look at what's the risk of not proceeding against the risk of proceeding. And my sense is that the benefits of fertilizing the ocean are really immense. And in particular, the restoration of fisheries is a really significant benefit, but then also the removal of carbon dioxide from the overall system. And we have to remember that a third of the carbon dioxide that Jason's now emitting out of his exhaust pipe, a third of that will end up in the ocean. And some of it will get turned into trees, but a lot of it will just stay in the air and add to the amount in the air. And so we need to find ways to stop the committed warming from past emissions, 1 trillion tons of carbon that has previously been emitted. And when we look at that scale, we really need to look to the world ocean as the primary scale of ability to operate at that gigaton multi-gigaton scale. We're adding 10 billion tons of carbon, 30 or 40 billion tons of carbon dioxide to the air every year. Now, 1 billion tons, that's 1 cubic kilometer. And the ocean has got more than 1 billion cubic kilometers of water. The ocean is just vast. There's more than twice as much ocean surface on our planet as land surface. And the ocean has got energy, it's got sunlight, it's got nutrients. Now, we need a new paradigm that says we need to utilize the ocean in order to repair and heal the earth. And now, iron is one of the really significant ways that we can do it. It's like the planet has gone anemic. It's like we've got a medical condition that we're in an emergency case, and we need emergency medicine, and ocean iron fertilization is part of the emergency medicine for the planet. Now, I want to mention another method of ocean iron fertilization, and that's called iron salt aerosol. And that's the idea that if you make so the most popular method of ocean iron fertilization uses a iron sulfur compound, but if you add an iron chloride, which is an aerosol, to the atmosphere, you can spread it out very thinly, and it has numerous positive effects. And I just find it really scandalous that the UN, the NGOs, the members of the scientific community have not really grasped the big picture, the strategic benefits, and the fact that we can do tests on these things, and if the tests don't work, then we can stop them, and no harm done. But if we don't do the tests, then like we're in the middle of the sixth planetary extinction due to our carbon dioxide emissions, and we really need to reverse the sixth extinction if humanity, civilization, economy are to have any future. And so we need that sort of a strategic vision, and it's just completely missing from the UN. It's missing from the scientific and NGO community. And so, like, I see geoengineering as absolutely necessary. And the idea that it's a bad thing is just a wrong idea that just needs to be challenged on moral grounds. It's a moral issue about the future of the
let me
planet.
ask this though. I think I really take your point that you need to compare the risk of doing with the risk of not doing. And that otherwise, you get a distorted notion. But we have not been paying sufficient amount of attention to looking at the risks of not using or either one, really. Everybody knows that global warming is going to be a catastrophe. We can predict a lot of that. But as for the potentially negative effects of using various kinds of geoengineering technologies, I don't think we talk about that enough. And unless we do talk about it, and then people really can't make that comparison between the risk of doing and the risk of not doing. So I think it's really worthwhile to say what might go wrong in terms of the worst pessimists that what do they say that we should watch out for that would be likely to be a serious problem, anything like as serious as the global warming that these technologies are designed to prevent?
So the nutrient robbing idea is that if we do ocean iron fertilization on a big scale, then in 1,000 years or something, it will affect the downstream. So it's quite a long-term problem. And then the whole oxygen cycle within the oceans is another really complex issue. But I think a key point here, Meta, is that what's needed is an incremental approach. Like if we start off with really small scale scientific, well-governed studies, then that will show whether this sort of speculative alarm that's been produced by politically motivated people and is really very dubious, it will show whether those criticisms are soundly based in evidence, or whether in fact it's true that they're just political scare campaigns, which is my assessment of them. So just take an incremental approach and do the science, and have it really well governed, have it international, provide the resources, get governments involved. Now, Jason might be able to tell us. I understand that the Canadian government was quite involved with the Haida project, but then when the NGOs such as Greenpeace and the ETC Group and the Guardian newspaper mounted this malicious scare campaign, the government lied about their, their past involvement. But so, you know, it just illustrates that it's been a big scandal that that needs to be exposed much more. And the Haida, as an Indigenous community, it was just so typical. Look at Canada's history of oppression of their Indigenous people and not listening to them. And then people just did not listen to the Haida people about the possible benefits for their economy and community. So perhaps Jason might like to add to those points.
Yes.
Well, I guess I would agree with you. I think it is. It's a bit silly. Well, it's telling that people didn't listen to the First Nation who really drove that particular project. But I can tell you that the government was only was not really that involved in the project. They were, I would say, overall, there was different. You know what? It's funny. A lot of times the left hand doesn't know what the right is doing and that sort of thing. And so, you know, some departments were supportive and others were not. Well, let's just call it that. And so, yeah, we require a more sane conversation. To your point, Robert, we require a more grown-up conversation because we know that the activities that we've undertaken now to cut carbon emissions globally has not worked in any way, shape, or form. It's just gotten worse. And I think it needs a broader understanding is, you know, we actually have brought some carbon emissions down in some sectors, in some areas. The issue is that we have developing nations who, you know, they're going to burn whatever they can, and they deserve to burn whatever they can to get to a more developed level. And we know we're going to get to 10, maybe 11 billion humans by 2050. So this problem is not going to go away. It's not going to get better. Recycling is not going to help. We need bigger solutions, and we need bigger conversations like this one that you were kind enough to host, Meta.
Well, you know, you mentioned that you had developed a measure, some way of some metric or some technology for measuring the effectiveness of some things. Could you elaborate on that? And would your technology for measuring these things be of any value for a variety of other potential climate repair technologies, or is it specific to the kind of rice husk approach that you're using?
So it's not specific to that. Again, you can look up Google patents. You can see the patent that we have. It's the patent on I can't remember the exact name of it, but it's a patent on how to measure carbon sequestered through the activities of ocean iron fertilization. So that it is specific to that. It's not specific to a type of iron or a type of application of iron. It's specific to the ocean and measurement from the development of a plankton bloom as a result of the addition of iron. Mm-hmm. With respect to the work that we're doing in soils, we have not patented that. I think the validation and verification of carbon sequestered in soils has a long ways to go due to the innate variability of soil and environmental conditions and human applications. I think it's much more difficult. I think, again, and Robert has said this fairly eloquently during this discussion, is if we're going to tackle problems of this scale, we need to take a look at where we can actually tackle problems of this scale. I mean, the ocean is 71% of Earth. 95% of it is out of sight of land and on average 4 kilometers deep. And in general, it is devoid of micronutrients, but has more than enough macronutrients to support plankton. The only reason it doesn't support plankton and sequester carbon thereby is because of the lack of micronutrients, particularly iron. But there's others, zinc, copper, and other cations.
But let me
So,
end with one
Just,
question here.
if I could just add one thing, Meta. Now, Jason said that so much of the ocean is has low nutrient and minerals, but he's talking about the ocean surface. As he mentioned, on average, the ocean is 4 kilometers deep. That's just crazy, when we think about it, because it's only like the top 500. There's a barrier called the thermocline, which is that the top of the ocean is warmer, and then below the thermocline, which is usually about 500 meters deep, it's cold, and underneath that barrier, the ocean is really rich with nutrients, but all of those nutrients can't get up to the surface, and so finding ways to get those deep nutrients up to the surface presents an absolutely massive planetary resource that we could use to repair the climate if we could work out how to do it. So working out how to understand the ocean, and I think Jason's point about the difficulties of measuring the effects of iron are really critical in terms of you actually have to get out there and do it, because there's all sorts of speculation about what will the effect be. Like, will the krill eat it up and then go back up to the surface? Will it circulate in the surface water? How much of it will fall to the bottom? They're really complex. You can't just do it in a laboratory. You have to actually go out and do the tests in the field.
Well, that was actually relevant to what I was about to ask anyway, which is that I have recently been hearing about an additional method of climate repair that is supposedly standing on its own, or can be of value in itself. And that is machinery or devices of some kind, which provide upwelling of the deep water to the surface. And I had heard of these being used in regard to the plankton, these farms, the seaweed farms that are being proposed. Brian von Hertzen being the leading person that I know of in that connection, that he has some sort of gadget that pumps water from below up to the surface so as to feed the plankton.
Brian's taking a different approach. What he's doing is, rather than upwelling the deep ocean water, he is sinking the kelp farm. So overnight, he takes the kelp farm, which is like a big bicycle wheel, 100 yards across, and sinks it down to the thermocline, where the kelp gets bathed in the high nutrient water, and then in the morning, just like the kelp do, just like the krill do. So it's a biomimicry. They go down into the deep ocean. So the krill come up to the surface at night and go down in the day. I think I might be wrong there, but with the kelp forest, the marine permaculture method that Brian is developing in the Philippines, they bring the kelp up to the surface to soak in the sunlight in the daytime, and then they sink it down below the thermocline at night in order to suck in all of the nutrients so that they can optimize the growth.
Okay, that's useful information to me, but it is a little different from what I had originally heard. Because originally, a year or two ago, when I first began to hear about Brian's experimentation, he definitely was talking about using a pump of some kind
Yeah,
to
that's
bring the
right.
water up. So, but the point I wanted to make in this connection is that quite apart from feeding seaweed farms, or any other good thing that we want to have done with these pumps. I'm hearing some people say that simply making a whole population of pumps that would somehow bring deeper water to the surface in itself it would be a major contribution. And in fact, I'm thinking of trying to find some people who are proponents of that intervention.
There's
To
been a lot of study of it, and so even James Lovelock, the inventor of the discoverer of the Gaia hypothesis of the idea of the Earth as a living organism, he had a major paper in which he said if you just have a giant tube that's bobbing up and down in the waves with a valve inside, then you can create a water flow so that it sucks in water at the bottom of the tube and emits water at the top. And then there was a series of scientific papers that was just trying to analyze what would be the effect of that. And one of the other big issues that comes with the upwelling of deep ocean water is that the deep ocean water contains a lot of carbon dioxide. And so if you bring it up to the surface, then some of that carbon dioxide will outgas into the atmosphere. So it's quite a complex question. And one of the things is, so there's this thing, the Redfield ratio, that everything's got like a ratio between carbon, potassium, and phosphorus and nitrogen in the ocean, and so there's a risk that so you need to find ways of doing the upwelling that won't just lead like if you upwell the rich deep water, then it will make the seaweed grow on the surface, but it might also just release a lot of that carbon that was previously stored in the deep. So it's quite a complex question, the upwelling, and yeah.
Okay, I've also heard that we did a terrible thing by killing so many whales because the whales go up and down constantly and stir so that you get an effect that runs counter to the stratification of the oceans. But they're not as
Whale poop is one of the best forms of carbon dioxide removal, because when the whales poop at the surface, it fertilizes the ocean and it creates food for the phytoplankton at the base of the food chain. And yeah, so the scale of the killing of whales was just such a horrendous genocide.
I want to give the last word to Jason because, yeah, you have some interesting things, information that I had never come across. What is your general verdict about all this conversation, Jason? Oh, is he frozen?
He
No,
does look frozen. Yeah, he's not moving.
he's frozen. Oh dear. Well, I did want him to have the last word. Uh,
There he is.
I think I'm back.
oh, all right,
Yep.
good. I'll
Sorry.
remove dead space when I edit. So tell us
Okay.
parting admonitions.
I think, from my perspective, I've realized I've been trying this, for a long time. And I think, we need to have, in order for this sort of work to become successful and commonplace, we need to find a way to allow capitalism a seat at the table. There needs to be a way. For me, I've found this methodology of moving into the agriculture space and sequestering carbon in the soil. That's the way that I'm able to contribute at this point. I hope people can use our patents, which are out there. They can use our patents to test ocean iron fertilization. I think an important point that people often miss about ocean fertilization is and carbon in the atmosphere is that carbon in the atmosphere is from the bottom of the ocean. That's where it came from. The oil and gas reserves all over the world used to be the bottom of the ocean. And the carbon in those oil and gas reserves is the result of hundreds of millions of years of plankton growing and dying and other whale carcasses, fish carcasses, whatever. Carbon from the surface going to the bottom. And so all those gigatons that we've emitted need to go back to where they came from, which is in the deep ocean. I think that it's very obvious when you look at our blue planet that the solution is in the blue and not the brown and the green.
Well, that's a very interesting and uplifting proposal. I'm all for it. So I think Robert probably is too. So thank you very much, both of you. It's been fun and interesting, and I think valuable to other people. So I expect we'll probably have an audience of people who want to have a listen. Thank you both and have a great day. Okay? Bye.
Thanks, Meadow.
very much,
Appreciate
Meadow.
the time.